So we have a question about the formulas of ionic compounds, and so one example was given here is the formula of the ionic compound from sodium and chlorine. So I have my sodium, which is Na, and chlorine, which is Cl. The first thing I have to do is figure out what the charge is going to be on those ions when they form ions. Because it's an ionic compound, we're going to form ions. We have a metal and a nonmetal. So I look at sodium and I see that it's in the first column of the periodic table, which means it has one valence electron, and it will lose that valence electron to form a +1 charge. So we don't write when we have +1 or -1, we just use the sign, we don't put the number with it. For chlorine, I look at it where it is on the periodic table, and it's over in column 17. And so it has 7 valence electrons, and remember it wants to have 8 valence electrons, so it's going to gain 1 electron, so it's gaining 1 negative charge, so it's going to have a -1 charge for its ion. The next thing I do is look and say I'm going to crisscross down. So I'm going to go ahead and write the ones in here just to make this a little bit easier for us for right now. So when we do the crisscross down, we take the charge on the cation, and it becomes the subscript on the anion. The charge on the anion becomes the subscript on the cation. We drop the signs because we're just trying to figure out how many of each ion we need. So we have Na1, Cl1, but anytime there's a 1, we don't have to include that, so it becomes NaCl. The thing we need to remember here is that ionic compounds, they're neutral. So what I want to think about is I have one sodium, which has a +1 charge, and I have one chlorine, which has a -1 charge, and together, so +1 -1 equals 0. So that's a way I can check to make sure I have the right number of each ion in the compound. So let's look at another example that is a little bit different because the charges are not 1. So let's look at aluminum and sulfur. So I look at aluminum on the periodic table, and I see that it has 3 valence electrons, so it's going to have a 3+ charge because it's going to lose those 3 valence electrons. Sulfur has 6 valence electrons, so it's going to have a gain 2 electrons because it wants to get to 8, so it has a 2- charge. Now I look at the crisscross down, so I take the charge on the cation becomes the subscript on the anion. The charge on the anion becomes the subscript on the cation, but I lose the signs. So when I write this one, I get Al2S3. I can check my math here and say, okay, well, there were 2 aluminums that each have a 3+ charge, plus 3 sulfurs, and I get those from the subscripts, that each had a 2- charge. And so what I get is +6 -6 equals 0. So I know that I've done it correctly because I have a neutral compound, and I know it's a neutral compound because it's overall an ionic compound, and those are always going to be neutral. Remember, if something has a charge, it's got to show that charge there. In this case, we had to figure out what the charges were.